let's start just from one consideration. The conventional model of life in modern biology is based on the concept that a living organism is made up of an ensemble of molecules kept together by chemical forces. In this vision, molecules are basically independent one of the other. So, according to the thermodynamics, the flow of energy through a living organism should occur in form of heat, because heat is the form of energy which is communicated molecule by molecule, whereas work is the energy transmitted through sizable ensembles of molecules and appear as free energy. There is a fundamental consideration in thermodynamics that shows that the conventional model is inconsistent, because, consider that, we living organisms exist at a temperature of 36, 37 centigrades that correspond to 310 Kelvin degrees, absolute degrees. According to the Carnot theorem, the yield of a thermal engine, like we are considered in the conventional model, should not exceed delta T divided T, where delta T is the variation of temperature within the engine. In our case, the variation of temperature does not exceed 1, 2, maximum 3 degrees. So 1, 2, 3 divided 310 is less than 1%. So the yield of our body considered as a thermal engine should be less than 1%. So a highly inefficient engine. However, according to bioelectrochemistry, the yield of the biochemical reaction occurring on the cell membrane, for instance, is in the order of 70%. What that means is that a gross violation of the second law of thermodynamics. Not at all. This implies only that energy is not flowing in our body as heat, but as free energy. That's it. And in order to flow as a free energy, our molecule needs not to be independent of each other, but they should perform in unison. They should act, the basic unity should be a large aggregate of molecules. Is that possible? The answer of quantum field theory is yes. Why? Because according to the basics of quantum physics, each physical object, either a particle or a field, should fluctuate. So, fluctuate spontaneously without external supply of energy. In a sense, energy is provided by vacuum, but not by us. So, we should have this fluctuation for free. And the problem is, as was told by Walter Nernst as far back as in 1916, is possible to tune together this spontaneous fluctuation of different atoms in order to get a unified body. A body and a large ensemble of molecules performing as a whole. This is the problem that at the time of Walter Nernst was not yet solved for the lack of conceptual tools, but in the following decades, the progresses of quantum field theory allowed to solve this problem. And it is possible to prove the following theorem. If large number of particles. Suppose charged particles. Atoms are made up of charged components, nuclei and electrons. So particles able to couple with the electromagnetic field. Now, we know that it's impossible to have an absolute vanishing electromagnetic field just because of the quantum fluctuation. The field fluctuates always, so there is always some small field around, and this has been proven experimentally in 1947 by the American physicist Willis Lamb, who got the Nobel Prize for that, that showed that the energy of the electrons orbiting around the proton in a hydrogen atom have energies which are slightly different from the energy calculated in the hypothesis of the total absence of an electromagnetic field, where the only present field was the Coulomb field between the proton and the electrons. There was a difference of energy of 1 part per million, which is a very tiny quantity, but is not zero. And this small difference, named Lamb shift, was accounted for by the theorist Feynman, Schwinger, Tomonaga, who got for this explanation also the Nobel Prize, who showed that this small difference is justified just by the interaction of the very tiny field produced by the fluctuation of the vacuum with the current of the electron orbiting around the proton. So, at that point, the quantum fluctuation, the electromagnetic quantum fluctuation of the vacuum are definitely proven. There is also the Casimir effect, other effect. And now we should consider what happens when a large number of bodies, of molecules, able to couple with the electromagnetic field are put in the present, they are always there, are in the quantum vacuum, and they interact with the fluctuation of the vacuum. What happens is the following. Under two conditions. First, the temperature is not so high. Temperature should be below a threshold, otherwise the thermal collision will destroy the effect of coherence. So, first condition. Second condition, the density of the particle should exceed a threshold. So we need to have many particles in order to overcome many fluctuations. We need to have a large number of particles. When the density threshold is overcome, spontaneously the system transits from a state where all particles are independent and the electromagnetic field is only the field of the small fluctuation, to a different state where all the quantum fluctuation of the atoms tune together and molecules are moving in phase between two configurations of their inner structure, in phase with a large, in that case, a large electromagnetic field which is got just by the coherent sum of all the tiny fluctuation of the large number of electrons. This is the theorem, which is a rigorous theorem, absolutely orthodox. So in this sense, from a physical point of view, the heterodox vision is just a conventional vision. Our vision is absolutely orthodox. This theory can be found in the text. Unfortunately, quantum field theory is applied only to elementary particle physics, like the Higgs boson recently discovered, and non-particle physics, not elementary, is ignored. But, so, when this is produced, we got a coherent system. Coherent means that all the components have a definite phase, which is common to all the system. So we can distinguish the different state of matter in the following way. The gases are systems where all components are independent. So there is no correlation at all. By the way, the word gas was coined by a Dutch physicist who contracted the word chaos. Gas was a chaotic ensemble of molecules. Liquids are systems where the coherence emerges among the electron clouds of molecules, whereas nuclei remain non-coherent. And solids are systems where nuclei too become coherent. So in this way, liquid water is a liquid, so in liquid water, the electron cloud oscillates in phase. But there are many possibilities, considering the fact that the water molecules are many excited levels. So according to the level which is involved in the coherent oscillation, we have different kinds of water. In her presentation, Antonella Denino, next Friday, we describe how many kinds of water we can get. Of course, when we have external fields, this external field adapt to the quantum fluctuation of vacuum and allow a modulation of the kind of coherence we are able to get. And in this way, we can try to explain the amazing results got by Jerry Pollack and his collaborators about water near hydrophile surfaces, because the field produced, in that case it's an electric field, the electric field produced by the surface will modulate the coherence and allow a peculiar feature to the particular water. In our story, we addressed first the problem of absolutely pure water that, as my friend Vladimir pointed out correctly, is a theoretical water. But you know that physics proceeds through theoretical non-existing objects, a sequence of theoretical objects that at the end converge on the natural existing real system. For instance, the physics of Newton and Galileo ignored friction because it was a complication. So the theoretical bodies in classical physics are frictionless bodies. In our case, in the first application of the theory of coherence to water, we studied an ensemble made up by water molecules only, without any other contaminant, and the only variable that was considered was temperature, nothing else. In this case, we were able to prove that the lowest energy state was a state emerging from the oscillation between the ground molecular state and an excited state at 12 point something electron volt, which is just below the ionization pressure. So this coherent oscillation is peculiar. It is a result which applies only to water, is non-existent in other liquids, where the oscillation occurs between the ground state and an excited state, where electrons are less bound but still bound. So in this case, in this other liquid, the oscillation doesn't produce any almost free electron. In the case of water, the coherent oscillation that occurs between the ground state of the molecule and the state at 12.07 electron volt is an oscillation that produces 1 electron per molecule almost free. So, in this large aggregate, whose size is 1/10 of a micron, molecule move in unison and produce a pool, a reservoir of almost free electrons. So, in this sense, the oscillation occurs between a ground state where water is an insulator because all the electrons are tightly bound, and another state where water becomes a semiconductor because there is 1 electron per molecule which has a very tiny binding residual to get these electrons free by a very gentle perturbation. So, this result, by the way, produces observable consequences, because if we consider a system made up by coherent water and non-coherent water, now we will see what is liquid and non-coherent water, on the interface we have a jump of potential. So we have a pi, because from one end we have almost free electrons, on the other end we have an insulator, so we have a jump of potential on the interface. We have calculated theoretically what is the order of magnitude of this difference of potential, and we found that depending on the excitation of the system, we have a difference of potential between 50 and 100 millivolts. This is just the order of magnitude of the membrane potential. So we would speculate that it's not the membrane which produces the membrane potential, but it's the membrane potential which produces the membrane through this difference of potential. Okay. Now, how large is this, we term this region coherence domain? How large is this coherence domain? It's just the wavelengths of the electromagnetic mode responsible for the formation. The 12 electron volts correspond to a wavelength of 1/10 of the micron. So the size of this coherence domain is 1/10 of the micron. Now, particular phenomenon of water. Since we have this reservoir of quasi-free electrons within the coherence domain of water is a unity still excitable, because we can have coherent excited level of the coherence domain, and coherence domain is able in turn to have its own oscillation. So, repeating the same theorem as before, beyond the coherent aggregation of molecules within coherence domain, we can have also coherent aggregation of coherence domain into larger superdomains, and so on, and so on. So, at last, we get a hierarchy of a nested coherence domain. The smallest one, larger, larger, still larger, and so on. By the way, introducing also the oscillation of the electric dipoles of molecules, we were able many years ago to prove the existence of a coherence among the coherence domain whose size is just about, we calculated the 450 microns, which is just in the order of the depth of the easy water. So, we encouraged by this result, we tried why we don't try to address the beautiful results of Jerry Pollack and try to include them, in spite of the objection of Jerry, within the framework of quantum field theory. Is that possible? That won't be a major success for quantum field theory, because facts are always true by definition. Theory could be true of this. Now, let's go ahead, eliminating illusions. Now, just a minute. The role of temperature. Of course, the thermal collision among molecules counteract the attracting effect of coherence. So, we have a competition between the thermal movement and the electromagnetic attraction. As a result, we have that at each temperature, a fixed number of molecules remain coherent, and the other molecules are non-coherent. So we have a coherent fraction and a non-coherent fraction. This result is well known in physics, applies to liquid helium, for instance. In the Landau model of liquid helium, there is a coherent fraction and a non-coherent fraction. Unfortunately, continuous turmoil, so that in the average, in bulk water, you cannot observe a permanent coherence, because since experiment applied to localizable region, in a given region there is a continuous transition between coherence and non-coherence. So in bulk water you can infer the existence of coherence from the thermodynamics. We are able to derive all the results of thermodynamics just by the theory of coherence. But if we are able to produce regions where the effect of the thermal collision is screened by some other effect, we are able to observe coherence for a long time. And this is occur just in the region close to hydrophile surfaces, because in that case the attraction between the surface and the water molecules compensate the effect of thermal collision, protects molecules against the effect of thermal collision. So in this region, the coherent fraction becomes almost unity, and we can observe directly what is a coherent water. By the way, as Jerry has observed, the water close to a surface for a depth which can be reached just by this nested coherences dynamics is different from the other water. It's different in the right sense of the coherence, because in a coherent region you cannot touch one molecule without touching all the others, because they are all correlated. And all the effect can be explained just by this correlation. Not only, but since this is a coherent region, and it is well known that the transition from coherence to non-coherence, according to the result of Isaac-Rabi, occur in an oscillating way, the so-called Rabi frequency observed in the laser. In the center, you have a coherent region. This region becomes non-coherent. From non-coherence, transit again to coherence. This transition does not occur in a straight line, but occur by oscillation. And this oscillation can be calculated, and in the case of water, is 4.6 electron volts that correspond to a wavelength keep strong 270 nanometers. So when you apply a radiation of 270 nanometers, you induce a transition in the coherent water. What do you observe? But there is a result that just impressed us, which is not yet contained in what I have said so far. And is the fact that each water is electrically charged, whereas water, as observed in nature and as calculated in the theory developed so far, is neutral. So, what is the origin of this charge separation observed? But not only, but it's a peculiar charge separation, because suppose that you have a surface negatively charged, for instance, like an amphion or like a DNA, which are a high density of surface and negative charge. What you observe is that the layer of water close to the surface is also negatively charged, without any positive charge in between, because you can just recall the argument of Feynman of like slide. But in that case, you should have a positive charge in between that attract from the two sides the negative charge. And this is not observed in the case. You have negative charge on one side, negative charge on the other side, and no other charge in between. The positive charge are mysteriously repelled on the opposite side of the layer looking to the bulk water. Should the surface be positively charged, just the opposite occur. So in this sense, it looks like the Coulomb law is just reversed in the sense that like charge is attracted and opposite charge repel, contradicting the general law of Coulomb. How is that possible? And this is just one of the miracles of the theory of coherence. Why? Because when an ensemble of particles is able, for some reason, to oscillate in phase, this phase oscillation produces a decrease of energy. So the system becomes stable on a lower level of energy. So according to the general law of physics, this state is preferred. The system just tends to realize this possibility. Now, in the case of water near a surface, and this is the case of surface like naphthalene or like biomolecules, like DNA, we have almost free charges on the molecular level. Almost free charges means charges which are bound, of course, to the molecule matrix, but are able to make oscillations. So, this oscillation produces a collective plasma oscillation corresponding to the whole surface. It's possible to start coherence should the temperature be low enough, not so high, but suppose that you have that this oscillation becomes coherent. Since coherence implies always a decrease of energy, we have a candidate to reach a still lower state, the almost free electrons of the water. So the almost free electrons of the water are faced with the almost free electrons, free negative charges of the surface. And they could consider the possibility. Could we dance together? And in this way, by dancing together, produce a further decrease of energy? And the answer is yes. Why? Because chemistry just prescribes what is the frequency of oscillation of the charged surface. But the frequency of oscillation of the free electron of the water is almost free, because the coherence domain of water can collect from the external noise, from the ambient noise, energy which is stored for a long way, because the lack of friction implied by coherence give a very long lifetime to the excited level, so they can adapt in time and produce whatever frequency you need, in particular the frequency of the surface, the hydrophile surface. So it's always possible for water to mimic the same frequency of the surface. By the way, is what justifies the effect, the homeopathic effect on the grains of sugar. You have the surface of sugar and the water, the excited water, in solution, in the aqueous solution, interface with the ground, acquires just the same frequency. So the frequency of the body is transmitted, becomes also the frequency of the water. And together with Pierre Amado, which is present here, we studied also the droplets of water emerging from the waterfall in the Alps. And Pierre was able to prove that these droplets are negatively charged, sometimes also positively charged, are electrically charged, and have the size just of our coherence domain. And these are quite stable in the sense that droplets are present for a very long distance from the waterfall, whereas smaller aggregates that are kept together by the conventional force decrease very rapidly when going far from the waterfall. What that means? That the conventional short-range forces produce very unstable aggregates, whereas coherence produces very stable aggregates able to survive, but not only, but electrically charged. Why electrically charged? Because the water flow comes down from a river which is flowing along banks, and the interface between the bank of the river and the water produces just the easy water, which is electrical charge. So, in this way, we presume to have contributed in this way to the understanding of the dynamics, the inner dynamics of easy water. And this I end here.
I can take some questions for you here.
Do you think the negative charge is responsible for the feeling of good health when we are near the waterfall?
Yeah, in the sense that for some reason I don't know, and geophysicists could explain, negative charges are preferred with respect to positive charge in the bank rocks. You know that the charge depends on the nature of the solid surface. That means that the solid surface facing the river are negatively charged. For reasons of geophysics. Excuse me, can you repeat?
So you just spoke about droplets being collected from a waterfall and you found an electric charge associated with them. Did you look at water that was taken from the bulk of the runoff from the waterfall?
Essentially, one should consider just the way of formation of the waterfall. Possibly, at the beginning of the fall, there were plenty of rocks inside, because almost the whole mass of falling water was electrically charged. That means that almost the whole mass was interface water, in a sense. That means that the surface, that the rocks were widespread in the beginning of fall that produced the result. But actually, Pierre should give a more suitable answer, because I'm a theorist. So I'm considering theoretical waterfalls in order to see the real waterfalls.
Just on your last question.
Yes, could you speculate about what would be the diffusion coefficient of water next to the interface, within the interface layer, compared to bulk water?
What coefficients?
Diffusion.
Diffusion.
Translational diffusion.
Unfortunately, I'm an old man. I walk in the sun field. In a coherent system, in principle, there should be no diffusion, because diffusion is the phenomenon of movement, of random movement, of single molecules within a medium. In a coherent system, all molecules are correlated. So what we have are movements which depend upon the force produced by fields. By the way, we have studied the phenomenon of Belousov-Zhabotinsky phenomenon, which it has been discovered depends also on water. This phenomenon disappears when the level of water in the system decreases below a threshold. So it means that water plays an essential role. And we can say that on the boundary of the coherence domain, we have a jump of the field from a high value to zero. So we have a strong gradient of the field. And this gradient acts just as an accelerator of particles. So in this way, particles are driven by this force. They don't diffuse anymore. They perform movement according to applied forces. And this accounts why the so-called, between quote, diffusion rate is so high in a particular arrive because there is an accelerating force. And this could be, this gives rise also to other particular phenomena. I will say, because of the existence of this gradient force, a gradient force in physics could be proven is proportional to the gradient and is inversely proportional to the particle of matter dipole. So, since electrons have a mass 2000 times smaller than protons, in a molecule, electrons are driven the square root, the dependency on the square root of n, 50 times more strongly than nuclei. So molecules in this way get stretched and acquires an additional electric dipole. For instance, this has been a very interesting result. Carbon dioxide in the empty space should be an almost as a noble gas, because carbon dioxide is a totally symmetric molecules. 2 electrons from one side, 2 electrons from the other side. So there are no hooks where other molecules could just tie. And in this sense, the carbon dioxide should have the same chemical reactivity as nitrogen, as a noble gas. And it should be also very bubbly dissolved in water, because there are no mechanisms. On the contrary, we know that the solubility of carbon dioxide is very high, not only, but its chemical reactivity in water, not in the empty space, is very high. How is that possible? Because this gradient force produces a stretching of the molecule that correspondingly loses its coherence, its symmetry, and acquires a strong electric dipole, and through this electric dipole can interact with the electric dipoles of water to produce the carbonic acid, for instance.
Yes, thank you.